Hi, my name is Magnus. I work as a Scala developer at SpeedLedger. And Scala is obviously for everyone, not only for Java developers. And I encourage everyone to just have a look at a couple of new languages, like every now and then, because you learn so much from new languages, even if you just take some of the main features into your own language, or then maybe you get stuck, as I did, and just want to continue down a certain path, like functional programming. And like a good question is always, why would you use Scala? Because all the hipsters do. Really good reason. But also because you have so many small things that improve your productivity and flow, so that when you compound all of them together, you get such a nice development experience. It's really expressive and concise, and compared to Java, you get rid of return statements, you don't have to print out the types, you don't need semicolons, you can get rid of brackets, and all of that makes it so much easier to read, and since you spend probably at least 10 times as long reading the code than writing it, I think it's good with really readable code. And it also makes it a lot easier to model the code and just show the business stakeholders what you're really after, and then make sure that you've understood them correctly before you start implementing something really fancy. So val means that you have an immutable value, and it's very common, or basically everything you do in Scala is immutable. And the exception is that you have something immutable. So immutability goes all through, and that helps a lot when you come to concurrency, because you don't get any weird bugs because of it. And if you like, you can type out the type and just add the value. And it's going to say that, yeah, you have an int that has the value of 5. Or then you can just skip the type because it's going to be inferred for you. And since there is a lot of different opinions on if you should type out and have the type there so that you can see it or not, you have beautiful, nice, modern IDEs where you can just turn on that, yeah, please clutter my code with all the types that I don't want to see. And then the people that don't want it can just turn it off so that everyone gets their own way. And it gives exactly the same result. And for functions, you have to add types to the parameters that you get in, but the return type can be inferred, so you can skip it here as well. And the brackets we were talking about earlier, you can just skip them. So as long as it's one-liners, you can skip the brackets. And yeah, it's all of these small things added together, which makes it more readable. And you'll get the type signature of an add function, which accepts 2 ints and returns an integer. And to call it, it's just the normal syntax. You throw on the 2 parameters and you'll get something back. So, has anyone ever had, or like the past week, how many people have had a null, some kind of null exception in production? 3 persons. 4. So few. I don't know if I believe you, but it's okay. So why do you usually have null exceptions? I would say that there's plenty of reasons, but one could be a function like this. Get DB user. Obviously, if you find the user, you're going to return it. It's the obvious case. But how many would return a null if you don't find the user? Couple of people. How many would throw an exception? Also a couple of hands up. And that's the thing, you don't really know without looking at the implementation. So if you're just reading through the flow, you won't know how to handle if you don't get the user. And since it's more of an edge case, you might not even think about it or look for it. And you might start getting exceptions in production instead because you're not catching them properly. In Scala, you would use an option. You can do it in Java as well, but it's not as idiomatic. In Scala, you do it all over the place. So I think I can count on, like, I can't even remember the last time I had a null reference exception in production. And I think that's the great thing. And with the option, you basically say that, yeah, either I'll return a value, or it's going to return nothing. And all of those weird bugs that you get when you start trying to use concurrency, or just the unexpected things, because somewhere along the chain, the object you sent into the function is actually modified. So when you when you use it in the next step, you have some kind of weird bug, which is really tricky to find. So even without the concurrency, the mutable state can give you so many problems. And it also gives you so much code. I can understand that you can't really read this because it's really small. But the only thing it is a user which have orders, and the orders have products. And you could do this immutable in Java by using constructor. But what happens when you want to update one single thing? You would have to send everything into the object structure again, and it's such a pain, so nobody really does it. In Scala, you would use a case class, which is basically a immutable class, which you can also compare, so that if you have the same values in the class, it makes the comparison true for you. While in Java, if you compare two things and you haven't overridden the equals, you won't get the same result, or it's not going to be comparable without manual interference. And then you add another property and you forget to add it to the equals. What happens then? You have another small bug. In the case class, you just type out the parameters you want, and they're going to end up as properties on the class. So here, we have the exactly same behavior as in the previous slide, but it's a bit more readable, and you can reason about it. And if we add the rest of the code, here we have the same behavior as in the last slide, in 3 lines. And I would say it's quite readable, at least to me. You could almost go back to a business person and show them this, and they'd understand it. So it's at least something to talk about. And if we want to populate it, it's no magic, except that you can skip the new keyword here. Because when you use case classes, you can just have the class name and then use the constructor, which is really handy. We'll get back more to the case class later, because there is so much more goodies in it. Yeah, I know. In the internal implementation, they're also doing the same thing, but you never have to see it, which it makes it so much easier to read. And then we have the options, and you use them instead of null. And I would say to make the intent more clear. And there's so many things in the language that helps you utilize the options as well. So if we look at this, to just set a value, you use sum, and it's going to infer the type that it's sum of string. And if you don't have a value, you set none. And here, the normal case would probably be that you can either have a value or you don't. So in this case, it's going to sometimes set Java forum, and sometimes it's going to return null. And to get the value, you use get or else, which exists in Java as well. And if there is a value, it's going to pick that one. Otherwise, it's going to pick the default value. You can also obviously check for values within the option. Now we come to the case class. So they're immutable, as I said. And it's really concise syntax. But I would say like the main thing is like the extractors and the copying parts of it, because that makes them so easy to work with, even if you want to update something. Because when you update the case class, since it's immutable, it's just going to return a copy of itself with the updated value and all of the old values still in place. And the extractors will go through here. Okay, so let's create a user again. You can either use it as a new user, if you like clutter in your code, and then just send in the parameters. It's going to give you the user. Or you can call user.apply, and all case classes get an apply method. And it basically has the same use as a constructor, but it's the thing that makes so that you can skip the new keyword in front of the case class. And for if you have classes that are not case classes, you can also add apply methods for those so that you can skip the new keyword. And this will give the same result as the previous one. And then you can just remove all the extra things and just say, yeah, I want a user, and these are the values I want in it. So they all give exactly the same result with slightly different syntax. So what happens if I want to update one parameter? I mean, this was like a whole structure of different classes. You use the copy. So what's going to happen here? Or can anyone tell me what's the value I'm going to get in my user case class? Yeah. Yes, Magnus forum. So it keeps all the properties that the case class had, and that goes if you have like a tree structure of classes as we had before, it's going to keep all of those and just update the one that you use copy for. And you can put several parameters in there if you like, and just set new values to them. And it doesn't affect the original object, but returns a new one, which is the whole point of the immutability. So that makes it so much easier to work with immutable objects, so that you can actually do it, or like that it's worthwhile. The companion object, which I talked about, which I didn't mention, but the apply method goes in the companion object, and the companion object has the same name as the case class. And in this case, I added a definition for from string, but I could have renamed it to apply as well. If you add several apply methods which accepts different arguments, then you can use any of them when you want to instantiate the class. In this case, we accept the name as one string, and then we split it on space so that we get the first and last name. And the apply method always returns the case class that has the same name. So in this case, it's the user. So if we want to use this, we just use user.fromString, and then we get a new user back. If we would have named it apply, we could have just typed user and then sent in the one string, and we would have gotten a user back. So it's just a type of overload. So pattern matching, how many of you like switch statements? A couple. It's sort of nice, but it's always tricky. Like, are you missing some options? Are you matching everything? And also, it's a bit cumbersome if you could have like different types in to match on it. And Scala helps a lot with that. And also it helps with extraction of values. So let's have a look. So we have our user, and in this case, since we care so much about GDPR and just love it, we make the surname optional so that you can create a user with or without a surname. And then we make a function where we take a user as an argument. and then we match. And we say that case user means that if the type is user, it's going to match. And it's going to assign the first name to the fname variable. But the second parameter, the none, is actually a filter. So it means that it's only going to match this first case if the user doesn't have a surname. And then we can print out the first name and just say that, yeah, we didn't have a surname. So it makes really powerful matching without ifing, and like you get rid of a lot of nesting things because you can check several things at the same time. And I would still claim that it's quite readable. And if we don't care about a variable, then we just put underscore, which means that we take any value, so we're not filtering on it, but we don't need it assigned to anything or extracted. And here, we say that we have both a filtering function, which says that, yeah, it has to have a value. And then from the option that we have there, we actually extract the value and put it into the last name variable. So we have like a combination of things that we do here. And it's a little bit of learning, but you get used to it really quickly. And in this case, we can say, yeah, so we got the last name, and we didn't care about the first name. And a trait is a bit of a hybrid between an interface and an abstract class. So you can have some implementations there if you like, or you can have nothing to use it more to like type things together. And in this case, we'll create a customer and an employee. They're both some kind of person. And then we'll create a nerd and a user, which are also persons. And here we come to really the other fancy thing about the pattern matching. Since we can match on type and also extract values from it, we can say that if it's a customer and it's a VIP customer, it's going to go into the first case. And the pattern matching always works so that as soon as it finds a happy case, it picks it and goes into it, and it doesn't evaluate the rest of the cases. So it's good practice to put the least restrictive cases in the beginning, or no, most restrictive cases in the beginning, so that you don't get false positives. And then if you like, you can have like a default option in the end. And if we don't have a value, we can also match on that, just the type. And since it's so easy to create objects like this, it's a quite nice way to get something that's strongly typed. And instead of customers or something like that, we could use this to create a like error hierarchy. And then we could know that we match on all the errors that are actually available. Because in this case, if we wouldn't add the last option that we match on everything, we would get a compiler warning. And I would say if it's a new project, then you can also tell the compiler or tell your environment to treat warnings as errors, and you can pick what warnings should be treated as errors. And I think this is a really good one to treat as errors, because if you add another type of person, you would get a compilation error, and therefore you wouldn't end up in the place where you miss to match on something. Do you have a question? Yes, it does, but there is no use for it here. If you add an S like that in the beginning, then you can just put variables into the text with a dollar and then the variable name, so that it's this string interpolation. Partial functions are functions that can be combined together to create something bigger. And a good reason to use partial functions is that you can match on different things, or like if you have rule engines, you can like add the different rules together. In this case, we have a list with an int and a string. And then the mapping function, we do a pattern match. So if you use the curly brackets and then case, then you're gonna get an automatic pattern match so that you don't have to use the match statement. It makes the code easier to read. And it's gonna return a list of the int and the string. We don't do anything with the values. But if we add a type to the list that we're not matching on, we'll get an exception. And that's good in some cases, and not so desirable in other cases. So instead of the map in this case, we could use the collect. And the collect does something really nice. It only picks out the values that you're interested in. So say that you have a long list of different values, and you have specific rules for some of them, and you just want to ignore the rest, then you can use collect. So instead of having to filter out the values you can actually use, just use the collect function, and whatever cases you match on, you'll run the code for, and the rest are ignored and not returned. I think that one is so powerful. Yes? Yes, it's the same thing as using a filter and a map. But you would basically have to have the pattern matching twice, or some kind of filter saying what you want. Okay, so let's look a little bit more at the functional parts. I would say that one of the main ideas is to transform instead of mutating and iterating. And also, you can easily combine functions into bigger ones. And also, it gives you a really nice flow. So let's have a look at an old style function, Java function, that returns the longest string. So we have a list of strings, and we want to find the longest one. And then we want to return that string. So we create a string, and we create a length, and then we iterate over each string. We check if the length is longer, and if it is, then we update the string and the length, mutate them, so you couldn't run this in parallel. And then it goes over all the strings, and in the end it returns the longest string. If you do it with streams, I'm not the Java stream expert, so maybe you can do it more nicely, but I think this is quite concise. So you sort by length, and then you pick out the first one. Quite handy, I would say. But I don't know. For me, it still takes a bit of reasoning, even though it's short and concise. It takes a bit of reasoning for me and reading through the code before I actually understand it, and I'm sure what it does, especially the last part. I could easily mix the -1 and 1, and I would get the shortest string instead by mistake. In Scala, you could just do the same thing with a max by function. And in the max by function, yeah? Ah, thank you. You can't really see it. And I can't really... Okay, we'll it's almost visible, but you use a max by function, and then you say what variable you want to look at. Yeah. Yeah. It should be just... It doesn't help. Nope. I will skip that one. It's a nice max by function, and it's a one-liner. A good question. There is an underscore dot length here, and instead of giving a whole lambda function, where you take the where you assign the parameter, and then you have the arrow, and then you use it, you can use underscore, and that's going to be the value that you're getting into the function. So it's just a shorthand so that you don't have to type out the whole lambda function. And then you pick out the length parameter because that's what you want to max by. So let's have a little bit another look at the map. The map is used to transform values and make new ones. So if we define a function, string length, which takes a string and returns the length, another way to write it is with a lambda function. So we assign the lambda function to the variable s-length. They do exactly the same thing. They get the same signature. It looks a bit different here, but for the compiler, they are the same. And if we look at the definition of a map, it takes a lambda function and transforms the value into new type, optionally into new type. And if we put our example into here, we see that we get an int back, and it wants a lambda function, which takes a string and returns the integer. And the traversable basically means that, yeah, it should be a list which you can just go through the elements. So the map function, as we saw, wants a lambda. So we can either type it out ourselves. We can use the underscore syntax, which we saw before. Or we could pass in any of the functions that we defined. So there's a couple of different ways to write the same thing. And that's sometimes what people complain about in Scala as well. That, yeah, it's really nice, but you can do everything in so many ways. So it's hard to set the coding standard that everyone follows. I haven't really suffered that much by it, but we're quite a small team, so I guess that we talk to each other and sort of agree on how we want to do stuff. Yes? In some cases you need them, in others you don't. But yeah, no, if you want to make something bigger, yeah, then you need the arrow functions. Oh yeah, yeah. I'm guessing that. Yeah, and depending on on the settings in IntelliJ, you can actually get it to be one character as well, or that it makes it into one. Just make sure that you set it out so that that's not what's sent to the compiler, but it's an IntelliJ setting, and I guess that I copied from different places in my code when I made this slide, or typed some of it in the slide and copied something else. Good catch. And once again, there is quite common that you get into the place where you have lots of values and you want to get rid of those that aren't interesting for you. And if you have a sequence of a sequence or a list of a list, and you want to get rid of all the empty ones, you can use flatten. And in this case, we'll get back Java Forum, Göteborg, Sverige. And it removed all the empty sequences from it. And since there's good support for the options in the language, it's going to remove all the none values here. So you'll get something similar, Java Forum Göteborg, but not it removes the nones. And then if we want to use that in a more practical manner, we have an example of products. And since there's a list of products in the orders, and a user has a list of orders, we have a list in a list, and say that we just want to pick out all the products that we have for all the customers. We could do it like this. So we iterate over each order, and for each order, we modify the array and add all the products to the list. We go to the next order, we pick the products, add it to the list. Or if we want to both flatten, so that we don't have a list in a list, and also map, basically saying what do we want from here, then we can use flat map. And this example does exactly the same thing as the code above. It goes through all the orders, gets the products, and returns a list of products. Easy to read? Quite. But what happens if you have a list of a list of a list? I don't know. For me, it starts to get a bit cluttered here when you have, because you're nesting stuff, and that usually doesn't make good readability. So what you can do instead is to use a for comprehension. And the for comprehension is basically just a flat map. So in this case, we pick the users, and then it takes the first user, and it takes out the orders, and it takes the order, and it picks out all the products. And then it goes back to the start, picks the next user, and all the products for it. And when you use a for comprehension like this, it's lazily evaluated. So when you're using the values, if you only use the top 10, it's not gonna go through all the users, because if you're happy after the 10 first products you got, and you don't process the values anymore, it's not gonna like drag up all of the database or whatever source you have underneath. So it's quite efficient. But it's also good to think about that don't close the database connection if you're doing something like this before you've actually used the values. But you'll find that one out quite fast. So concurrency. I would say that this is like one of the main reasons to use Scala. If you're having problem, or if you're using concurrency a lot, I think Scala is such a great choice. You can use Akka and other frameworks, or you can just use plain Scala, depending on the complexity of the thing you're trying to do. But there's so much built into the language, and with the purity, so that most things don't have side effects, and also the immutability, it makes it so easy to work with. So if we have a map or a sequence or a list, and we want to add 42 to it, you could either just map it normal way. If you want to make it parallel, you use the parallel collections, just add .par in between. And there's parallel collections for like vectors and lists and maps and like all the normal collection types. And you can also use futures. And in this case, we want to inverse the matrix. And since that might be costly, we want to do it asynchronously. So we wrap it in a future so that the rest of the program will continue on. And the last part of the code here, where we have the execution context, that's a part that we can skip because it's implicit. I'll go further into the implicits, but it basically means that if you have it in scope so that the compiler knows that, yeah, there is an execution context available, then you don't need to set the parameter explicitly. So how could this be used? Okay, so say that we want to get do some currency trading by dollars now when it's so really expensive. Then we can use the for comprehension. And what the for comprehension does is that it accesses the value that you get from the future, unwraps it, uses it, and the first two lines where we get the quotes, they're not dependent on each other, and they might be executed at the same time, and that's up to the execution context. And then the last part, then it recognizes that, oh yeah, you're using the two previous values, so it waits until the values have completed before it executes the last part, where we check, is it profitable to do this trade? And if it is, then we buy some kronas. So what happens if, and here we have is profitable. It's an if statement within the for comprehension, and that's a filtering. So instead of having to pick out all the values, filter them, and then on that act and buy, we can just put the filtering into the for statement. And if you do that, it requires the type that you're using to have both flat map and filter defined on it. But futures and lists and all of the like common things built into the language always have those types ready. And if you have your own types, then you can easily implement it. And then in the end, we take all the purchases, and for each one, we just print out that we did the purchase. And if it's not profitable, then we're not going to get anything in our list, and it's just going to keep going. So I've been doing Scala for 2 years, and when I started with it, there were quite some things that I found really, really confusing and hard to understand. One of them was like, what's the point of multiple parameter sets? Can't you just accept all the parameters the normal way that I'm used to? And the function definition looks the same. The way you use the variables looks the same. But the way you call the function looks different. One point could be that you more easily want to just make a new function where you add like one of the values, and then you can just use the function and add 3. So if you add 5 from the first function and then add 3 to it, you'll get 8. And you can make several like different default values or like different addition functions. Handy, easy, yeah, sure. But I mean, it's not that special. You could make a new function where you just take 2 parameters and then you then make a new one where you accept 1 parameter and then it add a default value. So I mean, that's, yeah, anyone could do that. But when we come to the implicits, It's where the magic starts happening. So here we have almost the same function definition as before, but we add an implicit y. And what the implicit y does is to start with nothing. If we just send in one parameter, nothing happens. If we send in two, it works. So what's the point? If we define a value that we say is implicit, then we can call it with one parameter. So in this case, we call it with 3, and it's going to add them together, and it's working. And the implicit parameters are most commonly used around when it comes to like execution contexts. So say for a web server or for executing futures, and when it comes to maybe serializing and deserializing JSON, for example, because then you probably don't want to, for every single function, say what serializer or deserializer you're using, because it clutters up the code a bit. It might be a little bit hard sometimes to find out what it was really that, or like what's really doing the serialization. But in most cases, it's really handy because it makes the code easy to read. And if you're looking for the serializers, I hope you have them all in one place, in one namespace, that, or like where it's easy to find them, or that they're implemented on a class. But it makes a huge difference that you don't have to add all of these implicit things every time you want to, say, execute a future, because I mean, they're all going to use the same execution context, I hope. And therefore, you can just import it at one place in the beginning, and it's going to be used everywhere. And I think that's really handy. So I encourage you to pick up Scala or any other new programming language. Have a go. See what you can take from it. And the next time somebody comes to you and says, could you please make this thing? We're only going to use it once, we promise. And then we'll throw it away. Pick a new nice language. Pick Scala, for example. Learn something new. And have a good time doing it while giving some value back. And then maybe you're lucky and they'll tell you that, oh, the thing you made last week, can we use it again? Yeah, sure, I have it here. And then when they come the next time and want to do this one-off, then you can do it in Scala again. And that's like a good way to start introducing Scala into your business. And maybe encouraging other team members to do the same. And in the end, you might be able to convince the boss that you can use Scala. That's it for me. Hope you enjoyed.